What if, in this very instant, the universe tore itself apart, unraveling the delicate tapestry of space and time, only to be reborn in a blinding flash of unimaginable energy? In the quiet moments of existence, when cities hum softly and oceans ripple beneath the moon's gentle pull, the cosmos moves according to rules invisible to the human eye. Every atom, every photon, every heartbeat of the stars dances along threads of fragile law, threads so fine that even a whisper of change could unravel them. And yet, hidden beyond our perception, the possibility lingers. A second Big Bang, a sudden, catastrophic rebirth of all that is, pressing the reset button on reality itself. Imagine the violence of such a cosmic awakening, matter and energy, spiraling outward in a blinding surge, time itself stretching, snapping, and reforming. The universe as a burning phoenix, collapsing into its own brilliance before rising anew. Galaxies, vast and luminous, trembling as if suspended on a spider's silk, fragile and fleeting, waiting for the inevitable pulse of creation. Every law we take for granted, gravity, the speed of light, the very flow of causality, could bend, fracture, and reform in ways our minds struggle to comprehend. Yet in that unimaginable rupture, there is also a strange elegance, a sublime symmetry, a rhythm of endings giving rise to beginnings. Philosophers and scientists alike have long asked whether creation is a singular, unrepeatable event or part of an eternal heartbeat of the cosmos. Could the universe, in its infinite vastness, harbor cycles of birth and death, each bang echoing faintly through the corridors of time? Perhaps our existence, brief and fragile, is a fleeting note in a symphony whose score we are only beginning to glimpse. And now, with our instruments and our equations, our observations and our daring imaginations, we confront the unthinkable. Could another Big Bang begin right now? If it did, would we witness it, or would the very fabric of our reality dissolve? Before our eyes, scientists have dared to ask, and the question lingers in the silent void: if the cosmos reset itself this instant, what would become of everything we know and of everything we are? In the quiet hum of a New Jersey radio tower in the early 1930s, Carl Jansky first heard the whispers of the cosmos. What seemed at first to be mere static, interference from distant thunderstorms, revealed instead a hidden voice of the universe, itself a faint, persistent hum, emanating not from Earth, but from the Milky Way. For the first time, humanity listened beyond the veil of visible light, tuning into a cosmos that had always spoken, but which we were only beginning to hear. It was a revelation that opened the mind as much as the instruments, suggesting that the universe was far stranger and more alive than previously imagined. Meanwhile, across the Atlantic, Georges Lemaitre contemplated a bolder vision. He imagined the universe beginning from a single, concentrated primeval atom, a dense seed from which all matter and energy had unfurled. To many, it was an audacious speculation, bordering on the poetic, yet it carried within it the mathematical elegance that would later anchor the Big Bang theory. Lemaitre's idea challenged conventional thinking, suggesting that the cosmos was not eternal and unchanging, but dynamic, evolving, and imbued with the memory of a violent birth. Even Albert Einstein, the great architect of space-time, wrestled with these notions. He had envisioned a universe balanced and static, a perfect cosmic stage. Yet the mathematics of his own theory of general relativity hinted otherwise, revealing an expanding or contracting cosmos. To maintain the status quo, he introduced the cosmological constant, a fudge against the truth he would later call his greatest blunder. The universe, it seemed, refused to be tamed by human preference. It surged forward, indifferent to our desires, expanding into a future no one could yet imagine. This expansion was soon confirmed. Edwin Hubble, peering through the powerful lenses of Mount Wilson Observatory, measured galaxies racing away, their light stretched into the red as if space itself were unfurling. The cosmos was alive with motion, and for the first time, humanity glimpsed a universe with a beginning, a history, etched into its very fabric. Then, in 1965, an accidental discovery by Arno Penzias and Robert Wilson revealed the cosmic microwave background, a faint, omnipresent echo of that primordial eruption. It was a whisper from the birth of everything, lingering across billions of years, a ghostly testimony to the violent, creative act that had set the universe into motion. And so the awe settled in. The stars, the galaxies, the very space between them, all bore witness to a beginning. The universe was not eternal. It had erupted into being once, and perhaps, in the hidden folds of time, it might erupt again. Each observation, each faint signal, hinted at the fragile, fleeting nature of existence, and the terrifying beauty of a cosmos that begins not with gentle growth, but with fire, explosion, and the untamable force of creation itself. The early 20th century was a time of quiet astonishment, when the universe slowly revealed itself as a far stranger realm than human imagination had dared to conceive. Jansky's radio waves, Lemaitre's primeval atom, and Hubble's receding galaxies were not isolated curiosities. Together, they began to sketch the outline of a cosmos that had a story, a history, a beginning. Each measurement, each faint signal from the heavens suggested that space itself was alive, stretching and expanding like a living membrane. The notion that the universe had erupted into existence from an infinitesimal point, rather than existing eternally and unchanging, struck scientists with both exhilaration and unease. It was as if the night sky, familiar and comforting for millennia, had suddenly revealed a hidden violence, a scar of creation written in the light of distant stars. Einstein's reluctant acceptance of an expanding universe became emblematic of humanity's struggle to reconcile intuition with observation. Here was the greatest mind of a generation, forced to confront the idea that the cosmos was dynamic, untamed, and indifferent to human desire for permanence. The cosmological constant, once a desperate patch to preserve a static universe, now seemed like a subtle acknowledgement that reality often defies expectation. Hubble's observations of galaxies retreating into the depths of space provided the first empirical evidence that the universe was not a static backdrop for human events, but a living, evolving entity. With every measurement, the certainty of a violent birth became more compelling, more unavoidable. The universe, it seemed, had a memory, a cosmic fingerprint left in every photon streaming through space, in every whisper of the microwaves left over from creation itself. The accidental discovery of the cosmic microwave background by Penzias and Wilson crystallized this understanding, offering a tangible relic of that primordial event. Here was proof that the universe had not always been as it is now. There had been a moment, billions of years ago, when all matter and energy were compressed into a single, incandescent point. The faint glow that filled every corner of the sky was a reminder that creation had been both violent and precise, explosive and meticulous, a balance so delicate that even the tiniest perturbation could have altered the emergence of galaxies, stars, and life itself. To contemplate this was to confront the fragility of existence, the thin thread of conditions that allowed anything from the simplest atom to conscious thought to emerge in the vast expanse of space-time. The philosophical implications were profound. If the universe had begun violently, erupting from nothing into the structured vastness we now inhabit, could such an event repeat? Could another Big Bang, in some hidden corner of reality, ignite a new cosmos, separate from or entwined with our own? The idea that the universe might be cyclic, that creation itself could be a rhythm, a pulse, a heartbeat reverberating across incomprehensible spans of time, began to take root. Scientists and philosophers alike felt the tension between empirical certainty and speculative wonder. The evidence pointed to a violent origin, yet the imagination yearned to follow that logic into the unknown, into a cosmos where beginnings and endings were not singular, but part of an eternal, unfolding story. Humanity's gaze, once limited to the immediate sky, now extended into the infinite, listening for the faint echo of creation, and wondering whether the next eruption of the cosmos might already be waiting in the dark. When Georges Lemaitre first proposed that the universe had begun from a single, concentrated point, the reaction was not awe, but incredulity. The idea of a violent cosmic birth clashed with the prevailing belief in an eternal, unchanging universe, the steady state, a cosmos imagined to be infinite in time, regenerating matter as it expanded, a perpetual, tranquil stage for the dance of stars. For many, the notion of a beginning was scandalous, almost blasphemous, as if suggesting that the cosmos itself had a moment of fragility, a memory of creation. It was in this climate of skepticism that Fred Hoyle, one of the most ardent defenders of the steady state, coined the term Big Bang, intending mockery. Yet in a twist of irony, the phrase endured, capturing the imagination of generations that would come to confront the raw, explosive majesty of the universe's birth. Scientists debated fiercely, oscillating between empirical evidence and the limitations of imagination. Could something so cataclysmic, so sudden, really have occurred? And if it had, could it ever occur again? The question began to haunt the edges of theoretical physics, not as mere speculation, but as a serious inquiry. Each new discovery lent weight to the possibility. Quasars and radio galaxies, emerging from the depths of space, glimmered as ancient relics, their light carrying the signature of a young, turbulent cosmos. These objects seemed to testify that the universe had been far from placid in its infancy, that violent forces had shaped the very scaffolding of matter, forging galaxies in the crucible of creation. Every photon arriving from the distant past carried a story of turbulence, a whisper of the universe's early convulsions amid the empirical triumphs. A philosophical unease settled over the scientific community. If the universe had been born, if it had erupted into being from a singular event of unimaginable energy, could it also die? Could the story of creation repeat itself in a cycle of birth, death, and rebirth that stretched beyond comprehension? In quiet offices and lecture halls, in the margins of journals, the idea of cyclic universes began to resurface, not as fantasy, but as a serious, though tentative, line of inquiry. The cosmos, once imagined as a steady and unbroken expanse, was gradually revealed to be dynamic, restless, and perhaps capable of rhythms and pulses far beyond human reckoning. And so, while the evidence for a singular origin mounted, so too did the whispers of eternity, the unsettling, poetic notion that creation might be a heartbeat, echoing endlessly through the corridors of space-time, each cycle a violent, luminous testament to the fragile, fleeting nature of existence. As the debate unfolded through the mid-20th century, the intellectual atmosphere was charged with both tension and wonder. Observatories across the globe trained their lenses on distant galaxies, measuring the redshifts that spoke of an expanding universe, yet many remained skeptical. To accept the Big Bang was to accept that the cosmos had a history, that time itself had a beginning, and that every structure we observed, stars, galaxies, clusters, had been forged in the aftermath of a singular, violent event. For some, this was unsettling. It implied fragility on a scale that dwarfed human comprehension. Hoyle and others clung to the comforting notion of the steady state, imagining a cosmos unbounded by beginnings or endings, a universe that could endure forever, indifferent to the impermanence that haunted human existence. Yet the mounting evidence began to erode even the most steadfast convictions. Quasars, emitting colossal energies from the earliest epochs of the universe, and radio galaxies, relics from a time when matter was still coalescing from chaos, illuminated the narrative of a cosmos shaped by cataclysmic forces. They were monuments to the universe's violent youth, silent witnesses to the primal upheaval that had sparked the expansion of all space and time. Amid the emerging observational data, theoretical physicists began exploring the unsettling implications of a universe with a finite beginning. If the cosmos could erupt into being, could it also collapse, or perhaps ignite anew in cycles beyond the reach of human measurement? The idea of a cyclic universe, once dismissed as fanciful, began to resurface, taking on a subtle gravitas. Richard Tolman's early models, proposing sequences of expansion and contraction, were revisited in light of new discoveries, suggesting that cosmic birth might not be singular, but part of a grand, recurring rhythm. In seminar rooms and quiet corridors of thought, scientists wrestled with the philosophical resonance of these models. The universe, it seemed, might be engaged in a pattern of creation and dissolution, a cosmic heartbeat echoing through time, each pulse a reminder of both the grandeur and fragility of existence. The speculation was as much poetic as it was scientific. A universe capable of ending, only to rise again, illuminated the paradoxical nature of reality itself, violent and beautiful, finite yet eternal. The human element of these reactions was equally profound. Researchers, confronted with evidence of a universe that had a violent origin, were forced to reconsider their place in the cosmos. The night sky, once a canvas of stability, became a ledger of cosmic history, each star and galaxy a fossil of events too immense to fully grasp. The philosophical weight of the Big Bang, its implications for beginnings, endings, and potential recurrence, rippled through both the scientific community and broader culture. Poets, philosophers, and theologians found new metaphors in these discoveries, imagining the universe as a cycle of destruction and rebirth, a phoenix that might rise from its own ashes. Even in the silence of laboratories, where instruments hum and data streams in from the edge of the observable cosmos, the question lingered: if the universe could be born once, could it not also be reborn? The whispers of cyclic universes grew louder, hinting at a cosmos whose story was not linear but circular, whose history might repeat in forms beyond human comprehension. A rhythm of beginnings and endings written across the fabric of space-time. Itself. In the decades following the first tentative glimpses of a universe in motion, theorists began to peer deeper into the mathematics of the cosmos, seeking patterns that might explain not only its beginning, but its ultimate fate. The notion of an oscillating universe emerged, a vision in which creation and destruction were not singular events but part of an eternal cycle, a cosmic pendulum swinging endlessly between the extremes of expansion and collapse. Richard Tolman, in the 1930s, pioneered models that explored this possibility with remarkable rigor. He imagined a universe that could expand, reach a peak, and then contract, only to be reborn in another cataclysmic surge of energy. Each cycle, in Tolman's vision, was governed by the laws of thermodynamics, yet with subtle nuances. Heat and entropy accumulated, but the universe somehow persisted, a restless entity that refused the permanence of stasis. These early investigations were as much philosophical as mathematical. To conceive of a cosmos without beginning or end was to confront the very nature of time itself. It suggested a reality in which existence was not a singular narrative, but a grand, repeating story, echoing through the corridors of eternity. Scientists wrestled with the paradox. How could entropy, the inexorable increase of disorder, coexist with a universe that rebirthed itself? Attempts were made to reconcile these ideas with the emerging understanding of thermodynamics. Yet the answers were incomplete, tantalizing glimpses of possibilities rather than definitive truths. The mathematics hinted at elegance, symmetry, and rhythm, but the data required to confirm these visions lay beyond the reach of contemporary instruments. Observational limitations loomed large. The precise rate of cosmic expansion remained uncertain, and the density of matter across the universe was difficult to measure. Without these parameters, the oscillating models could only suggest potentialities, whispering of a universe capable of rebirth, but refusing to reveal its secrets fully. Yet even in the absence of concrete evidence, the imagery was powerful. One could imagine the cosmos as a pendulum swinging gracefully through the dark, tracing arcs of creation and destruction. Each motion both violent and poetic, both finite in its instant and infinite in its recurrence. Galaxies formed, dispersed, and reformed in the mind's eye, not as discrete events, but as notes in a vast, unending symphony of cosmic life. There was a beauty almost haunting in its subtlety. To these early investigations, they suggested that the universe might not be a linear journey from birth to death, but a cyclical dance, a rhythm etched into the very fabric of space-time. Creation and collapse were not opposites, but partners, intertwined in an eternal choreography, even as observational science struggled to confirm the details. The imagination of the human mind traced the possibilities, envisioning a cosmos that was both comprehensible and infinitely mysterious. In this early era, before satellites and precise telescopes, before the mapping of the cosmic microwave background, the universe was already whispering its secrets, that time itself might bend, that endings could become beginnings, and that the violent birth of all things might be only one movement in an eternal, oscillating symphony of existence. As Tolman and his contemporaries delved deeper into the equations, the oscillating universe revealed both promise and paradox. The models suggested that each cycle, each expansion and collapse, would carry with it the memory of what had come before. Matter would compress into an almost infinitesimal state, a singularity poised on the edge of rebirth, and yet the universe would emerge again, transformed but recognizable, a phoenix arising from the ashes of its own history. Thermodynamics, the law that governs heat and disorder, seemed to impose limits, yet Tolman's careful calculations hinted at subtle loopholes, the possibility that entropy might not entirely accumulate, that each new cycle could start afresh in ways we could not yet fully quantify. These ideas were radical, even for a generation accustomed to imagining a universe without bounds. They suggested that the cosmos was not a one-time explosion but a grand, rhythmic pulse, a heartbeat of creation echoing through the void, imperceptible to human senses but written in the very fabric of space and time. Yet the universe, at that time, remained a stubbornly opaque teacher. Observational data were crude and incomplete. Telescopes measured the motion of nearby galaxies, but the details of cosmic expansion remained uncertain. The density of matter, the balance between gravitational attraction and expansive forces, could only be estimated with wide margins of error. Without precise measurements, the oscillating models could not be confirmed, only imagined, and yet the imagination itself became a tool of discovery. Scientists and philosophers alike began to see the cosmos not as a static arena, but as a living, breathing entity, one that could oscillate, expand, and collapse in patterns both terrifying and sublime. The mathematics suggested possibility, the imagination supplied poetry, and together they painted a picture of a universe that was both comprehensible and infinitely mysterious. The poetic resonance of the oscillating universe was irresistible. One could envision the cosmos as a vast pendulum, swinging through the darkness of space-time, each arc a moment of creation, each descent a prelude to destruction. Galaxies coalesced in the outward swing, stars ignited in the friction of cosmic motion, and as the pendulum reached its apex, the universe would pause, trembling on the brink of collapse. Then, in a silent, almost imperceptible moment, gravity would reclaim its dominance, drawing matter inward, compressing it into the seeds of a new beginning. The imagery of such a rhythm was at once terrifying and sublime, evoking the fragility of existence and the enduring beauty of cosmic law. It suggested that the universe, rather than a linear journey from birth to death, might be engaged in an eternal dance, a choreography of energy and matter whose cycles stretch beyond human comprehension, both cruel and magnificent in their inevitability. Even as the oscillating models remained untested, they inspired a profound philosophical reflection. Could existence itself be cyclical, with life, matter, and consciousness emerging repeatedly in an endless cosmic rhythm? What did it mean for humanity to inhabit a universe that might have endured countless iterations, each one beginning in violent birth and ending in collapse? These questions, once speculative, began to acquire a weight that mirrored the enormity of the cosmos itself. Early investigations into the nature of oscillating universes planted the seeds of modern cosmology's most daring ideas, that time might bend, that endings could become beginnings, and that the violent birth of the universe we observe today might be but one movement in a symphony without end, a rhythm both finite in its moment and infinite in its repetition, echoing through the corridors of space-time with the silent poetry of creation itself. The cosmos, once only glimpsed through telescopes and mathematical models, began to reveal its secrets with unprecedented clarity through the eyes of machines designed to perceive the faintest whispers of the early universe. Satellites like COBE, WMAP, and Planck scanned the heavens with exquisite precision, mapping the cosmic microwave background, the afterglow of the primordial explosion that had birthed all matter and time. These delicate variations in temperature and density, scattered across the sky like the faintest brushstrokes on a celestial canvas, told a story both ancient and profound. They confirmed that the universe had undergone an extraordinary burst of inflation, an early surge of expansion so violent and swift that it stretched the fabric of space itself, shaping the distribution of galaxies and clusters we see today. Each measurement, each subtle fluctuation, became a note in the symphony of cosmic history, revealing a universe that was dynamic, restless, and far more intricate than human intuition could grasp. The revelations did not stop there. In 1998, astronomers observing distant supernova made a discovery that would append previous assumptions. The universe was not merely expanding, but accelerating. Dark energy, the mysterious force driving this acceleration, dominated the cosmos, pushing galaxies apart with a strength that defied comprehension. The implications were profound and unsettling. A universe once imagined to collapse under its own gravity, perhaps to contract and initiate a new cycle, now seemed destined for a different fate. Instead of rebounding, it could tear itself apart, a scenario both terrifying and magnificent in its scale. The very forces that shaped creation might, in time, become agents of destruction, suggesting that the cosmos was not a static stage for human observation, but a dynamic, almost sentient entity capable of transforming in ways that echoed both its violent birth and the possibility of future upheaval. Speculation followed naturally from observation. If dark energy continues to accelerate the expansion of the universe, could it, in some unimaginable manner, trigger a phenomenon analogous to a new Big Bang? Could regions of space become unstable, collapsing locally even as the cosmos stretches outward, giving rise to bursts of creation hidden from our view? The frontier of cosmology had shifted. Creation might not reside solely in the distant past, encoded in the afterglow of an ancient explosion, but could lie ahead in events yet to unfold, in processes that might surpass human imagination. The universe, once thought to be a one-time miracle, now appeared to be an ongoing drama, a story whose chapters extend across billions of years, whose plot twists are written in the interplay of matter, energy, and the inscrutable laws that govern them. With each breakthrough observation, the mystery deepened. The precise maps of the cosmic microwave background revealed ripples and anomalies that challenged simple explanations, hinting at processes beyond known physics. Inflation, once a theoretical conjecture, had left indelible imprints across the universe, while dark energy suggested that the cosmos was more dynamic and unstable than even the most daring theorists had imagined. The horizon of scientific understanding stretched farther, revealing not just where the universe had been, but the terrifying and beautiful possibility of where it might be going. In this light, the act of creation was no longer confined to history. It was a phenomenon that might recur, that might surge unexpectedly, that might even arrive in ways so subtle yet so vast that humanity, perched on a small planet, would scarcely perceive the magnitude of the event unfolding. The universe had begun to speak in clearer tones, yet its language remained elusive, a poetic and terrifying reminder that the story of existence is not finished, and that the next chapter, whether calm or catastrophic, subtle or explosive, might lie just beyond the horizon, waiting to be born. The precision of the Planck satellite, in particular, offered humanity an unprecedented window into the universe's infancy. Tiny fluctuations in the cosmic microwave background, differences in temperature of mere millionths of a degree, revealed the seeds of all structure in the cosmos. These ripples were the blueprint from which galaxies, clusters, and the cosmic web itself would emerge. Yet, beyond confirming inflation, they hinted at subtleties that challenged conventional cosmology. Some anomalies suggested that the early universe may have been even stranger than predicted, with regions defying simple statistical explanation, whispering of physics beyond current understanding. These delicate fingerprints left by the first instance of creation imbued the cosmos with an almost poetic fragility, a sense that the structure of everything we see today was shaped by forces both subtle and violent, that the birth of space and time was a work of exquisite, precarious balance. Meanwhile, the discovery of dark energy transformed our understanding of the universe's trajectory. Once imagined as a cosmos that might slow, stabilize, or even reverse into a collapse, the accelerating expansion suggested a future of unprecedented scale and mystery. Galaxies now drift away from each other with ever-increasing speed, as if the universe itself was stretching the very fabric of reality. The implications were as beautiful as they were terrifying. If dark energy remains constant, the universe might never contract again, potentially preventing the cyclical rebirth envisioned in earlier oscillating models. Yet even this inevitability carries its own speculative possibilities. Some cosmologists have proposed that local regions of instability, quantum fluctuations, or interactions with higher dimensions could trigger bursts of creation, even as the larger universe expands toward eventual isolation. In this light, the question is no longer whether a second Big Bang could happen, but how, where, and under what hidden conditions it might emerge. A possibility both exhilarating and humbling in its scale. The convergence of these observations, precise mappings of the early universe, confirmation of inflation, and the unsettling discovery of dark energy, opened new horizons for speculation. The universe began to feel less like a finished story and more like an ongoing narrative, its past and future entwined in complex, perhaps cyclical, patterns. The act of creation, once considered a singular event, could instead be a continuous phenomenon playing out across cosmic time in ways that elude direct observation. Philosophers and physicists alike found themselves confronting questions that blur the line between science and contemplation. Could the universe contain the seeds of its own rebirth? Could the violent surge of a future creation already be encoded in the accelerating expansion hidden in the geometry of space-time, awaiting a moment to manifest? Each discovery, while illuminating, only intensified the mystery, revealing that the universe is both comprehensible and infinitely elusive, a tapestry woven with threads of energy, matter, and forces whose ultimate interplay may one day ignite phenomena as transformative as the original Big Bang itself. Even as instruments sharpened their vision, humanity remained perched at the edge of understanding. The cosmic microwave background, the relic radiation of primordial fire, spoke across billions of years, whispering hints of processes we have yet to grasp. Dark energy, enigmatic and dominant, challenges assumptions and forces reconsideration of even the most fundamental laws of physics. Together, they suggest a universe that is alive with potential, not static but dynamic, capable of evolving in ways that may exceed imagination. The very forces that shaped the early cosmos may, in a hidden symmetry, one day recreate it or transform it in ways that mirror its first violent birth. In this view, creation is no longer solely a memory, but a possibility, a question that stretches forward into the void, asking not only where the universe has been, but where it might surge again in a luminous, terrifying, and poetic echo of its own origin, as the universe expands with ever-accelerating urgency. Cosmologists have begun to imagine a future so extreme that space itself may be rent apart. This is the Big Rip scenario, a vision in which dark energy, the mysterious force propelling the cosmos outward, grows inexorably stronger. Galaxies drift beyond each other's horizons. Bound structures like clusters and solar systems are torn asunder. And eventually, even atoms themselves might be stretched into oblivion. The notion is terrifying, a cosmic dissolution on a scale so vast that the human mind can scarcely comprehend it. Yet even in this extreme, there is a strange beauty, a poetic symmetry, creation and destruction, birth and dissolution, entwined in a rhythm beyond time. A reminder that the cosmos is both violent and profoundly delicate. Amid these grand possibilities, quantum physics suggests that the universe may be fertile with potential. Tiny fluctuations in the vacuum of space, normally imperceptible, could give rise to entire universes, budding from nothing, self-contained and separate from our own. In these ephemeral quantum seeds, the act of creation is spontaneous, uncaused, a whisper of possibility in the void. Black holes, long considered, the ultimate tombs of matter, emerge as paradoxical engines of genesis. Theoretical physicists have speculated that the singularities at their cores could pinch off space-time, generating baby universes that expand independently, invisible to their parent cosmos. Here, the violent collapse of one world becomes the genesis of another, a cosmic cycle in which death and birth are inseparable, intertwined in ways that challenge every intuition about space, time, and causality. Even Stephen Hawking, grappling with the enigmatic boundaries of time itself, imagined universes with no initial singularity, where the fabric of space-time is finite but unbounded. In such models, the beginning and end of time are not points of rupture but smooth, continuous surfaces, a vision both elegant and unsettling. Meanwhile, string theory proposes that our universe might be but one brane among countless others, and that collisions between these higher dimensional sheets could ignite vast bursts of creation. A new Big Bang born not from a singularity, but from a cosmic rendezvous of immense, unseen dimensions. Each theory, each mathematical conjecture, adds layers to the mystery, revealing a cosmos more versatile, more imaginative, and more astonishing than humanity had ever dared to conceive. In the shadow of these unimaginable cycles, the fragility of human existence becomes starkly apparent. We are perched on a small planet within a fleeting moment of time, witnessing phenomena whose scales dwarf every human measure. The universe surges and ripples with forces that could remake reality itself, and yet within this vast theater of creation and destruction, consciousness emerges, reflecting on its own ephemeral place. There is an emotional resonance in this contrast. Our lives, brief and fragile, set against the enduring drama of cosmic cycles. From the inflationary bursts of the early universe to the potential Big Rip, from quantum fluctuations birthing entire worlds to black holes seeding new realms. In contemplating these extremes, humanity confronts both awe and vulnerability, the thrill of discovery and the humbling reminder that we are spectators to processes far beyond comprehension, witnesses to a cosmos in which creation is not merely past but an ongoing, unfolding mystery. The more scientists probe these possibilities, the more the universe reveals itself as a tapestry of paradoxes and extremes. Quantum fluctuations, normally dismissed as ephemeral and insignificant, may carry the seeds of entire realities. In the vacuum of space, where energy flickers in brief instants, a new universe might spontaneously emerge, detached from its parent cosmos, unobservable yet fully formed. Such a scenario suggests that creation is not confined to the singular moment we call the Big Bang, but is instead a continuous process, arising wherever conditions, however improbable, allow it to flourish. Each of these nascent universes could follow its own laws of physics, expanding, evolving, and perhaps even collapsing in patterns that are unknowable to any observer within our own universe. The cosmos, in this vision, is not a static stage, but a generative field, alive with potential, in which the act of creation is embedded in the very structure of existence. Black holes, long feared as the ultimate endpoints of matter and time, reveal an equally provocative possibility. The singularity at a black hole's core, where density and curvature become infinite, may pinch off a fragment of space-time, birthing a baby universe that grows independently of its parent. Matter disappears from our universe, yet may be preserved in a newly formed cosmos, a secret ledger of creation hidden within the heart of collapse. This interplay between destruction and genesis challenges every intuition about causality and permanence. What we perceive as endings, stars collapsing, galaxies evaporating, black holes swallowing all in their path, may instead be transitions. The universe recycling itself in ways both terrifying and magnificent. Each black hole becomes a portal, a locus, where the violent energy of one reality seeds the beginning of another, reinforcing the notion that creation and destruction are inseparable partners in the cosmic dance. Even the boundary conditions of time itself invite reflection. Stephen Hawking's work suggested that the universe might have no sharp beginning, that time, like space, could be smooth and finite, curving back on itself in ways we cannot easily visualize. In this framework, the act of creation is less a singular eruption and more a continuous unfolding, a surface upon which universes are traced and retraced in a pattern that transcends conventional chronology. String theory adds yet another layer of complexity. Our universe may be one of many branes, sheets of existence floating in higher dimensional space. Collisions between these branes could ignite new Big Bangs, sending ripples through space-time and spawning realms beyond observation. Each theoretical model reinforces the same haunting insight. Creation is not an isolated event in the distant past, but a process that may be ongoing, hidden within phenomena we can barely begin to comprehend. Amid these vast possibilities, the contrast with human fragility is overwhelming. Earth, a tiny sphere suspended in space, is both cradle and spectator, orbiting a star that itself is ephemeral on cosmic scales. Civilizations rise and fall, civilizations that will never witness the full sweep of cosmic cycles, yet are capable of glimpsing their outline through observation and mathematics. The emotional weight of this perspective is profound. Humans, brief and finite, look out into a universe of unimaginable scale and complexity, where creation, destruction, and rebirth unfold across dimensions and time spans that dwarf comprehension. There is both terror and awe in realizing that the universe's cycles of birth and collapse may be constant, indifferent, and hidden, and yet that consciousness exists to reflect on them. Each quantum fluctuation, each black hole, each brain collision becomes not only a scientific curiosity, but a metaphor for the delicate balance between fragility and endurance. A poetic reminder that humanity is both insignificant and extraordinary, observing a cosmos that may be eternally birthing itself anew, at the extreme edge of scientific inquiry Humanity confronts a boundary beyond which our instruments falter and our theories strain. Telescopes, no matter how precise, capture only the light that has traversed billions of years, revealing the aftermath of creation but never its first instant. Particle accelerators, our most powerful tools for probing fundamental forces, smash matter together at energies far below those that prevailed at the universe's birth. And yet, beyond these limits lies the Planck epoch, a shadowed frontier where space and time themselves are thought to dissolve into uncertainty. Here, at scales smaller than the tiniest fraction of a proton, the familiar laws of physics, those equations that describe motion, gravity, and energy, break down. The fabric of reality, as understood through general relativity or quantum mechanics, becomes a turbulent sea of probability, a domain where the very notions of beginning and end, cause and effect, may lose meaning. The tension between quantum mechanics and general relativity is nowhere more acute than at this boundary. Quantum theory governs the smallest scales, the behavior of particles and fields, while general relativity describes the curvature of space-time and the dynamics of massive bodies. To unify these frameworks is to seek a language capable of describing both the infinitesimal and the infinite, a challenge that has occupied the greatest minds for decades. Loop quantum cosmology offers one glimpse of a possible resolution, suggesting that the universe might undergo a bounce, a contraction to a minimal volume followed by expansion, avoiding the singularity of classical models. In this vision, the violent birth of a Big Bang is not the absolute beginning, but a transformation, a transition through a domain where conventional physics surrenders to a deeper, subtler order. Speculation grows bolder still in theories of the multiverse. Our universe may be one of countless bubbles, each expanding in higher dimensional space, each governed by slightly different laws of physics. Collisions between these universes could spark localized bursts of creation, phenomena analogous to Big Bangs that occur invisibly to observers trapped within their own cosmos. Even if direct evidence remains elusive, the mathematics suggests these events are possible, painting a cosmos far more intricate than any single universe could convey. Science peers toward this veil, attempting to glimpse structures and dynamics that lie beyond light, time, and perception, probing the outermost edge of knowledge, while recognizing the limits imposed by the cosmos itself. In this extreme domain, the human imagination becomes as essential as empirical measurement. The Planck epoch, the multiverse, and bouncing cosmologies are not merely abstract theories. They are portals through which we attempt to comprehend the ineffable, to touch the origins of existence itself. There is a poetic resonance in this endeavor to stand at the precipice of understanding, gazing into a darkness that refuses definition, and yet sense patterns, possibilities, and rhythms that hint at a hidden order. Humanity peers through this veil with a mixture of awe and humility, aware that the answers may forever elude direct observation, yet compelled to continue the quest. In confronting the extreme edge of science, we glimpse both the limitations and the boundless potential of reason, the fragile human capacity to explore a cosmos that may stretch infinitely beyond the grasp of sight, touch, or time. As scientists peer ever closer to the Planck epoch, they encounter a universe that resists conventional description. Space and time, once thought continuous and smooth, appear to fracture into discrete granular units, a foamy, jittering substrate that defies intuition. In loop quantum cosmology, These granules of space-time prevent the formation of true singularities, suggesting that the Big Bang may not have been a moment of infinite density, but rather a transitional bounce from a previous phase of contraction. In this framework, the universe is cyclical at a fundamental level, each cycle a rhythmic pulse in which energy, matter, and geometry transform but never truly vanish. The mathematics is exacting, but the implications are poetic. Creation is not a singular eruption, but an ongoing process, echoing through an eternal landscape where the veil of the Planck epoch is simultaneously a boundary and a gateway. The universe, at its most extreme, becomes both fragile and resilient, a paradox that challenges human understanding while inspiring it in equal measure. Beyond the limits of direct observation, the concept of a multiverse introduces dimensions of speculation that border on the sublime. Our universe, one bubble among countless others, might be colliding with neighboring realms in higher dimensional space. These collisions, invisible and untouchable, could unleash energies comparable to the Big Bang, sparking new universes even as the parent cosmos continues its expansion. The mathematics suggests a cosmos teeming with possibility, where creation is not confined to a single locus or epoch, but distributed across an infinite ensemble of realities. These ideas, once considered fringe, now find support in string theory and other advanced frameworks. They hint at a reality that is simultaneously intimate and overwhelming. Every fluctuation, every quantum event may be the genesis of worlds beyond our perception, unfolding silently in spaces that defy ordinary measurement. In contemplating these extremes, the emotional resonance becomes unavoidable. Humanity, perched on a small planet within a finite span of time, is faced with the enormity of processes that unfold on scales both vast and minute, spanning epochs and dimensions that will never be fully observable. There is beauty in this fragility, the capacity to reflect, to wonder, and to model universes we cannot see. Science itself becomes a form of poetry, an attempt to map what lies beyond perception, to understand rhythms and patterns that exist outside human experience. The edge of knowledge is also the edge of imagination, a place where calculation and speculation entwine, where mathematics gestures toward phenomena that may never be directly witnessed. In this light, the veil beyond the Planck epoch is not simply a limitation, but a horizon, a space of infinite potential, a reminder that the universe is both a mystery and an invitation, urging us to contemplate creation not as a static monument of the past, but as a dynamic, ongoing, and profoundly beautiful process. Even as telescopes and accelerators inch closer to the fundamental limits of measurement, the cosmos maintains its secrets, teasing with glimpses that both illuminate and obscure. Each theoretical breakthrough reveals more possibilities, universes that bounce, dimensions that collide, energies that flare unseen, and a space-time that resists the very notions of beginning and end. The extreme edge of science, though unreachable in totality, stretches the mind to its limits, demanding humility, curiosity, and a recognition that our understanding is a candle flickering in an infinite darkness. Here, at this precipice, creation itself seems fluid, mutable, and eternal, a narrative that continues to unfold even beyond the grasp of comprehension, where the laws of physics bend, boundaries dissolve, and the act of existence becomes a question both scientific and profoundly poetic. Among the prevailing frameworks of modern cosmology, the inflationary universe stands as one of the most compelling, proposed to resolve the puzzles of uniformity, flatness, and the absence of observed magnetic monopoles, inflation posits a sudden, almost inconceivable burst of expansion in the earliest fractions of a second. Space itself stretched at a speed faster than light, smoothing wrinkles in the fabric of the cosmos and planting the seeds of structure in minute quantum fluctuations. Eternal inflation, an extension of this idea, suggests that while one region of the universe slows into familiar expansion, other regions continue to inflate, generating new pocket universes in an unending, fractal-like process. In this view, the cosmos is not a single, bounded arena, but a vast, branching multiverse. Each universe its own stage of creation, each a potential cradle for matter, energy, and life. It is a vision at once mathematically rigorous and poetically overwhelming, a cosmic symphony in which beginnings are neither singular nor final. Cyclic cosmology offers an alternative narrative, one in which the universe experiences rebirth in endless sequences. Instead of a single Big Bang, these models propose a rhythmic alternation of expansion and contraction, a cosmos that breathes with the heartbeat of creation and collapse. Each contraction is not merely an end, but a prelude, a gathering of energy and structure that primes the next expansion. Loop quantum cosmology, in particular, replaces the classical singularity with a quantum bounce, suggesting that the universe never truly reaches infinite density. Matter and energy are compressed to their limits, then released in a new cycle of cosmic birth. Such theories resonate deeply with the human imagination, evoking images of the cosmos as a pendulum, a breathing organism, a celestial rhythm that transcends the linearity of time and the fragility of individual existence. The ekpyrotic model introduces a more exotic perspective rooted in string theory, envisioning our universe as a brane, a higher dimensional membrane moving through a vast, unseen landscape. Collisions between branes could release energy sufficient to trigger Big Bang-like events, creating universes in sudden bursts. This scenario suggests that creation is not a singular event, but a consequence of interactions in a higher dimensional realm, where the rules of our familiar space-time are only a shadow of a deeper, more intricate reality. Even heat death, the eventual fading of stars, and the dissipation of usable energy may not signify an ultimate end. Quantum mechanics hints at tunneling events, rare fluctuations that could spontaneously nucleate new universes from the vacuum, giving rise to pockets of creation long after the familiar cosmos has grown cold and dark. Yet, for all their elegance and mathematical beauty, these mainstream theories share a common limitation. The evidence remains fragile. Observations of the cosmic microwave background, large-scale structure, and the distribution of matter provide tantalizing hints, but they cannot yet confirm the deeper mechanisms these models propose. Each theory is a candle held against the darkness, illuminating possibilities, but leaving much concealed. And so, while inflation, cyclic bounces, ekpyrotic collisions, and quantum nucleations offer profound visions of creation, they also remind us of the limits of knowledge, the boundaries beyond which speculation stretches to meet the unknown. They are both achievements of human ingenuity and invitations to wonder, compelling us to imagine a universe that is far more dynamic, complex, and eternal than even the most daring intuition might suggest. Inflationary theory, while elegant, opens doors to questions as profound as the answers it offers. The initial burst of exponential expansion, occurring in less than a trillionth of a second, set the stage for every galaxy, star, and planet that would follow. Tiny quantum fluctuations, magnified to cosmic scales, became the scaffolding upon which the universe built its vast structures. Yet eternal inflation suggests that our observable cosmos is but one bubble in a frothing sea of universes, each separated by vast stretches of inflating space. Some regions may never stop expanding, creating a multiverse in which creation is constant, unending and diffuse, an endless proliferation of possibilities. This vision challenges intuition and philosophy alike. If countless universes exist, each with potentially different laws of physics, then our own universe, and indeed life itself, is simultaneously remarkable and inevitable, a fragile spark in a boundless cosmic landscape. Cyclic models push this rhythm further, offering a universe that is simultaneously finite and eternal. Each contraction compresses space, time, and matter to near incomprehensible densities, yet quantum principles may intervene to prevent true singularities. The concept of a quantum bounce reframes what had long been considered a catastrophic end as a prelude to rebirth. In this light, entropy, the inexorable march toward disorder, is not an ultimate barrier, but a step in a recurring process, where energy, momentum, and structure are repurposed, recycled, and reborn. The poetry of this vision is irresistible. The cosmos as a grand pendulum, swinging endlessly between birth and collapse, each cycle leaving traces of the last, each expansion a continuation of an eternal story. Humanity, observing a single slice of this rhythm, glimpses only a fragment of a vast unceasing symphony, yet in that glimpse there is profound meaning, a reflection of resilience, transformation, and possibility at scales far beyond human perception. The ekpyrotic model situates this cycle within a higher dimensional stage, where branes drift and collide, igniting universes in sudden bursts of energy and light. Our own cosmos may have emerged from such a collision, the result of interactions beyond the confines of our observable reality. These collisions suggest that creation is relational, dependent on the motion and interaction of entities in a deeper space beyond our own. Similarly, quantum tunneling from a heat-dead universe offers a counterintuitive form of persistence. Even after stars have burned out and galaxies have faded, rare quantum fluctuations could ignite new universes, spontaneous acts of creation, emerging from the vacuum itself. In such a universe, death is never final, and beginnings can arise from endings in ways that stretch the imagination and defy conventional causality. Despite the mathematical rigor of these mainstream theories, observational verification remains elusive. Subtle signatures in the cosmic microwave background, patterns in galaxy distribution, or traces of gravitational waves may eventually hint at the processes behind inflation or cyclic bounces, yet for now they are largely theoretical constructs. Their fragility does not diminish their power, however. Rather, it emphasizes the daring nature of human inquiry. Scientists stand at the edge of the observable, peering into a cosmos that is at once profoundly knowable and astonishingly mysterious, where each hypothesis, inflation, cyclicity, ekpyrotic collisions, or quantum tunneling offers a different lens on the ultimate questions. How did creation begin? How might it continue? And could it ever recur in forms beyond our comprehension? In exploring these models, humanity does more than calculate. It imagines, it speculates, and it participates, however indirectly, in the ongoing drama of the universe itself. At the fringes of cosmology, theories become as audacious as they are provocative, inviting imagination to step beyond the boundaries of conventional observation. Lee Smolin proposed a vision of cosmic natural selection, a universe not singular but evolutionary, where black holes are more than endpoints of matter, they are seeds of creation. Each singularity, compressed to extremes, may spawn a new universe, inheriting subtle variations in the fundamental constants of physics. In this framework, the cosmos itself is a living process, iterating through cycles of birth and collapse, optimizing conditions for complexity and structure across generations of universes. It is a poetic and unsettling idea. The same mechanisms that destroy matter might also generate worlds. The violent heart of a black hole giving rise to new realms, echoing through time in ways imperceptible to any observer within a single universe. Even stranger are the implications of Boltzmann branes, hypothetical self-aware fluctuations arising spontaneously from chaos in an otherwise uniform or heat-dead cosmos. If the universe persists long enough, rare statistical fluctuations could briefly assemble consciousness from disorder, ephemeral minds appearing for no reason other than probability. These thought experiments confront philosophy as much as physics, raising questions about the nature of perception, reality, and existence. If consciousness can emerge from randomness, then what is truly real, and what is merely a transient flicker in an indifferent cosmos? Here, the boundary between science and metaphysics blurs, suggesting that the very act of observation, the presence of awareness, may be as fundamental to understanding the universe as equations or photons. Speculation extends even further into the realm of simulations, where our cosmos could be interpreted as a programmed environment subject to resets, reboots, or experiments by entities beyond comprehension. In such a framework, a second Big Bang might be a designed event, a restart of cosmic computation, a way to explore alternative outcomes or test universal parameters. This vision, while speculative, resonates metaphorically with scientific models of cyclic or branching universes, highlighting the philosophical interplay between causality, contingency, and design. Even more exotic are ideas of time reversal, where the arrow of time itself might invert, triggering a collapse and subsequent explosion, a cosmic reset enacted by the deepest symmetries of physics. These scenarios, while far from empirically verified, expand the imagination, reminding humanity that creation could occur in modes we have yet to conceive, in rhythms beyond our perception. In contemplating these fringe theories, the emotional and philosophical texture deepens. Universes may be born, die, or flicker into existence like fleeting dreams, endlessly waking into new dawns of possibility. The cosmos becomes a hall of mirrors, each reflection a potential reality, each pattern a whisper of creation's boundless ingenuity. Esoteric philosophies intersect here, suggesting that science, in its pursuit of empirical rigor, is also a form of metaphysical inquiry, probing the edges of existence itself. Within these speculations lies a profoundly human impulse to seek patterns, to imagine continuity, to find meaning in the silent, immense void. Whether through black holes, statistical anomalies, simulations, or time's reversal, the universe presents itself as a living story, one that merges mathematics with poetry, physics with wonder, and observation with the deep, unending question of how and why creation might happen again. Exploring the notion of cosmic natural selection, one begins to see the universe not as a static arena, but as an evolving entity, where black holes act as reproductive engines of reality. Each collapse may encode subtle variations, changes in physical constants or particle interactions in the universe that emerges on the other side. In this vision, universes that favor complexity and structure are more likely to survive, in the sense that they produce more black holes, generating further progeny. The cosmos becomes a vast evolutionary laboratory, a mechanism of trial and variation written across space-time itself. The implications are staggering. The universe is not merely a backdrop for existence, but an active participant in its own perpetuation, a process of creation intertwined with destruction. Life, consciousness, and human reflection are but tiny notes in a symphony whose scale and rhythm far exceed comprehension, yet whose existence may ultimately be shaped by the same cosmic principles that govern the formation of stars and black holes. Boltzmann brains push this vision into the uncanny. In an eternally inflating or heat-dead universe, random fluctuations could spontaneously assemble self-aware entities, isolated islands of consciousness that arise, ponder, and vanish without leaving traces in the wider cosmos. These ephemeral minds challenge every assumption about continuity, identity, and reality. Could such fluctuations, appearing briefly in a vast, indifferent void, have any meaning beyond their fleeting existence? They force a confrontation with the uncomfortable possibility that the universe may contain entities that are self-aware, but fundamentally disconnected from causality, reflections of chance rather than intention. In their strangeness, they act as a mirror to our own perception, reminding us that consciousness, no matter how coherent it seems, is fragile, contingent, and inextricably bound to the conditions of existence. The human mind, in contemplating these possibilities, senses both insignificance and awe, perceiving glimpses of order amid an underlying chaos that may itself give birth to fleeting awareness. Speculation extends to the simulation hypothesis, a concept that has captured imagination precisely because it reframes the universe as a programmable construct. If reality is computational in nature, then a second Big Bang might represent a deliberate reboot, a reset enacted by forces beyond observation. In such a cosmos, creation is not solely a physical process, but a coded sequence, a design embedded in the structure of existence. This echoes, in metaphorical terms, theories of cyclicity, multiverse branching, and quantum fluctuations. The universe is malleable, contingent, capable of beginning again under conditions that may be imperceptible from within. Similarly, the idea of time reversal evokes a poetic symmetry. If the arrow of time were inverted in certain regions, collapse could trigger explosive creation, a new universe igniting as a consequence of processes hidden within the fabric of space-time itself. These visions, though speculative, suggest a universe that is fluid, recursive, and perpetually inventive. A cosmos in which the line between physics and philosophy blurs, and where imagination becomes an essential tool for exploration. At the intersection of these speculative models, the poetic imagery of creation emerges vividly. Universes flicker like dreams, collapsing and expanding, fading and reappearing, endlessly waking into new dawns of possibility. Esoteric philosophies intersect with cutting-edge cosmology, revealing a landscape in which scientific inquiry and metaphysical reflection are intertwined. The universe, in this vision, is a living narrative, a canvas upon which creation is continuously inscribed, sometimes violently, sometimes imperceptibly, but always with inexhaustible potential. Humanity, ephemeral yet reflective, observes this cosmic drama from a tiny vantage point, grappling with questions that may never be fully answerable. What is the nature of reality? What mechanisms drive creation? And could the cosmos ever begin again in ways we have yet to imagine? In contemplating these possibilities, black holes as nurseries of universes, Boltzmann brains flickering into being, programmed resets, and time's reversal, one senses the profound mystery at the heart of existence, that creation may be eternal, endlessly recursive, and as intimate to the laws of physics as it is to the poetry of human thought. Humanity's reach into the depths of cosmic origins has never been more ambitious, nor more tentative. Particle accelerators, colossal instruments of precision and energy, recreate in miniature the conditions that existed mere fractions of a second after the universe's birth. Protons collide at velocities approaching the speed of light, releasing torrents of energy that echo the ferocity of the Big Bang itself. Within these fleeting interactions, physicists glimpse hints of phenomena otherwise hidden, exotic particles, ephemeral forces, and the subtle signatures of symmetries broken or preserved. Each collision is a conversation with the cosmos, a probe into the earliest instance of time. Yet even these instruments scrape only the surface of the energies and densities that governed the universe's inception. The limits of technology remind us of the immensity of what we do not yet know, and the courage of human curiosity drives the quest forward, undeterred by the enormity of the unknown. Beyond the confines of Earth, telescopes like the James Webb Space Telescope peer into the infancy of galaxies, capturing light that has traveled billions of years to reach us. In the faint glow of these first stellar systems, scientists search for clues of primordial physics, the fingerprints of inflation, and the conditions that gave rise to matter itself. Each observation is a bridge across eons, connecting present understanding to the universe's earliest chapters. Complementing this endeavor, the emerging field of gravitational wave astronomy offers a new sense of perception, ripples in space-time, generated by massive events long past, reaching across the cosmos as echoes of its earliest dynamics. Collisions of black holes, neutron stars, or perhaps more exotic early universe phenomena carry information that electromagnetic light cannot convey, opening a sensory channel to events previously thought inaccessible. With each detection, the universe whispers more of its story, hinting at the processes that shaped the cosmos and perhaps the seeds of creation itself. Simulations of cosmic evolution have become another vital tool, allowing theorists to model the delicate interplay of forces across billions of years. Virtual universes are born on supercomputers, expanding, collapsing, or bouncing under the guidance of mathematical laws. These digital experiments test scenarios of cyclic cosmologies, quantum bounces, and potential collapse-triggered recreation, offering glimpses of possibilities beyond the reach of direct observation. Meanwhile, astronomers meticulously observe the accelerating expansion of space, attempting to quantify dark energy, that mysterious force shaping the universe's destiny. Its nature remains elusive, yet its implications are profound, if dark. Energy grows or fluctuates. It could trigger transformations on cosmic scales, perhaps even phenomena analogous to a new Big Bang. Amid these efforts, the human dimension is undeniable. Each discovery, each simulation, each data point is the product of patient, painstaking labor and a willingness to confront the unknown with humility and imagination. Despite the limits imposed by distance, time, and scale, humanity persists in its inquiry, embracing both the possibility that we may never know the full truth and the inevitability that the act of asking itself is meaningful. Science at this frontier is as much an emotional endeavor as an intellectual one, a dialogue between consciousness and the cosmos, a recognition that the universe may forever conceal some of its deepest secrets, and yet beckon us onward with the promise of revelation. In the laboratories, in orbiting telescopes, and across the vast networks of computation and theory, the search continues, a testament to the enduring human desire to witness the birth, evolution, and potential rebirth of the universe itself. Even as instruments push boundaries, the universe retains its mysteries. Particle accelerators reveal fleeting glimpses of conditions near the birth of time. Yet the energies accessible in laboratories remain far below the extremes of the Planck epoch. Still, every collision illuminates fundamental symmetries and breaks them open to examination, offering clues about the forces that govern reality. Physicists search for evidence of phenomena such as supersymmetry or exotic particles that may have shaped the early universe, tiny breadcrumbs pointing toward a grander cosmic narrative. These experiments demand extraordinary precision and patience. The slightest variation in measurement could hint at profound truths or reveal entirely unexpected behaviors. In this meticulous pursuit, the universe becomes both teacher and enigma, challenging human intellect to reconcile theory with observation. Meanwhile, telescopes like the James Webb Space Telescope and its successors transport us across billions of years, capturing light from the earliest galaxies, some formed mere hundreds of millions of years after the Big Bang. Within this faint luminescence lie the encoded signatures of primordial physics, the distribution of matter, the clustering of galaxies, the chemical fingerprints of the first stars. Each observation allows scientists to reconstruct the conditions that governed the cosmos when it was young and volatile, revealing subtle asymmetries that may have influenced the formation of stars, planets, and ultimately life. These studies are complemented by the revolutionary field of gravitational wave astronomy, where space-time itself becomes a messenger. Ripples from the collisions of black holes or neutron stars, and perhaps from processes rooted in the earliest moments of the cosmos, provide information that light cannot carry, revealing the rhythm and resonance of cosmic creation on scales previously unimaginable. Simulations have become a powerful complement to observation, enabling scientists to model the universe under different conditions. Supercomputers recreate virtual worlds, tracing the interplay of gravity, dark matter, and dark energy over billions of years. These simulations test cyclic cosmologies, quantum-bound scenarios, and hypothetical collapses, exploring how universes might regenerate, rebound, or evolve differently under varied parameters. In parallel, the accelerating expansion of the universe, driven by dark energy, remains a tantalizing puzzle. Astronomers measure its effects on distant galaxies, striving to understand its nature, its constancy, or its potential to reshape cosmic destiny. Could this mysterious force eventually catalyze conditions analogous to a second Big Bang, a rebirth emerging from the expansion itself? The question remains speculative, yet it is taken seriously, grounded in rigorous measurement and careful inference. Amid these technical and theoretical advances, the human dimension persists as a quiet, poetic thread. Researchers devote decades of their lives to questions that may never yield definitive answers. Driven by the profound desire to understand origins, existence, and potential rebirth, each observation, calculation, and experiment is an act of dialogue with the cosmos, a meditation on scales of time and space that dwarf comprehension. There is an elegance in this endeavor, even as the universe stretches infinitely outward and inward into its quantum fabric. Human curiosity presses forward, bridging the infinitesimal and the immense, whether through particle collisions, telescope, imaging, gravitational wave detection, or computational modeling. The pursuit itself becomes a testament to human perseverance and imagination. In this ongoing struggle, the universe may remain inscrutable in its entirety, yet it offers fragments of revelation, each enough to inspire wonder, reflection, and the relentless pursuit of understanding the mysteries of existence, creation, and the potential for the cosmos to begin anew. In the vastness of the cosmos, humanity is infinitesimal, perched upon a fragile bubble of matter and life that has endured for mere moments against the backdrop of eternity. Our existence, luminous yet delicate, is set against a universe of incomprehensible scale, where galaxies drift apart in silence, and the forces that govern creation are indifferent to desire or intent. To contemplate a second Big Bang is to confront the limits of perception and imagination, the sheer violence, the sudden reordering of space, time, and matter would obliterate everything within the reach of our senses, leaving no witnesses to record the event. Yet even in the face of such annihilation, there is awe, an awe tempered by understanding, by the recognition that what is catastrophic to one form of life may be generative on a cosmic scale. Endings and beginnings are intertwined, bound, in a rhythm that exceeds human comprehension, echoing the cyclic visions proposed by the most daring of physicists. There is a paradox at the heart of this reflection. We ask what came before time itself, a question that stretches the mind into realms where causality may lose meaning and concepts of before and after dissolve. In doing so, humanity reaches toward the infinite, grappling with mysteries that are simultaneously scientific and existential. The universe, in its indifferent grandeur, offers glimpses of structure and law. Yet these glimpses are fragments, hints of an underlying narrative that may never be fully apprehended. And yet it is precisely this act of questioning, the attempt to trace creation, to imagine rebirth, to understand beginnings and potential repetitions, that defines the human spirit. Curiosity becomes a bridge between mortality and eternity, a means of participating in a story far greater than any single life. Even if a second Big Bang were to unfold at this instant, its light and force would erase all evidence of what came before. Our fragile bubble of existence would vanish, leaving the cosmos to continue, perhaps forming stars, galaxies, and life in ways unknowable to us. In this, there is a profound lesson. Creation is not a single event, and life is not the measure of cosmic significance. The universe is both destroyer and giver. Its cycles of expansion and collapse are testament to the persistence of energy, matter, and possibility. Endings are inseparable from beginnings, each echoing the other in rhythms that extend beyond perception, beyond understanding, yet accessible through the lens of thought, mathematics, and imagination. Perhaps the ultimate reflection is that the question is not whether another Big Bang will come, but whether creation itself is eternal, a story without a final chapter, unfolding in infinite variations across time, space, and possibility. Each cosmic event, each collapse, each flare of energy is a verse in this narrative, a note in a symphony whose music we may only partially hear. Humanity, in its smallness, is not insignificant, for in the act of wondering, of observing, of probing the depths of reality, it becomes a witness to the eternal dance of creation and destruction. The universe is not merely a stage on which events occur. It is an ongoing story, a cycle of beginnings without end, inviting consciousness, however fleeting, to recognize its own reflection in the vast unfolding mystery of existence. The contemplation of our own smallness against the cosmic canvas evokes a mixture of humility and wonder. Humanity exists as a fleeting resonance within a universe that has been unfolding for over 13 billion years, where stars are born and die in a rhythm we can barely perceive. Yet in this transience lies a strange power, the ability to reflect, to measure, to imagine the unfathomable forces that shaped reality. In tracing the story of the Big Bang and the tantalizing possibility of a second, we confront both the fragility and resilience of existence. We recognize that life, consciousness, and understanding are temporary alignments of matter and energy, glimpses of order amid chaos. The human mind, though limited in scope, becomes a prism through which the universe examines itself, translating the language of light, gravity, and quantum fields into thought, narrative, and emotion. There is a poetic symmetry in this. As the cosmos cycles through creation and dissolution, consciousness arises to bear witness, however briefly, to its own origin and potential rebirth. The very act of asking what might happen if another Big Bang were to begin right now illuminates the paradox of knowledge. We can model the processes, extrapolate from physical laws, and simulate extreme scenarios, yet the actual event would transcend observation. Our limitations are stark, yet they do not diminish the human drive to understand. There is beauty in this tension, the interplay between what can be known and what must remain mystery. Philosophers and physicists alike have long wrestled with the implications of a universe with a beginning and a potential recurrence. Is time itself a linear river flowing inexorably forward, or a vast ocean in which currents of creation surge and ebb in cycles beyond comprehension? Could the cosmos itself possess memory, patterns of recurrence that echo across epochs, or is each creation a singular, unrepeatable expression of fundamental laws? The questions are as essential as the answers, and in their very formulation, humanity participates in a dialogue with the infinite. Even if a second Big Bang were to ignite, its immediacy would render human survival impossible. And yet, life and consciousness, in some form, might emerge elsewhere in new galaxies, in different configurations of matter, under laws subtly altered by the forces that drive cosmic renewal. There is a profound lesson in this. Creation and destruction are inseparable. Endings are intrinsic to beginnings, and the universe, in its vast impartiality, writes a story that is continuous, recursive, and endlessly inventive. Human life is a brief stanza in an epic poem, yet our awareness of the cosmic narrative imbues that stanza with meaning. Through imagination, observation, and reflection, we align ourselves with the eternal rhythms of existence, recognizing in each collapse and expansion a reflection of our own fleeting consciousness. The cosmos is not merely a backdrop for life, but a living, breathing sequence of events, a story of energy and matter cycling in a perpetual dance, inviting us to contemplate our place, to marvel, and to wonder. Perhaps the ultimate reflection is that the universe is less a question to be solved than a story to be witnessed, a continuous unfolding of beginnings without end. Every Big Bang, every collapse, every subtle fluctuation of energy is a stanza in this cosmic narrative. In imagining a second Big Bang, in contemplating the cycles of creation, humanity touches the edges of eternity. Even if we are too fragile to endure the next cosmic dawn, our consciousness resonates with it in thought and imagination. The universe, in its grandeur and indifference, offers both terror and awe, destruction and creation, endings and beginnings, woven seamlessly into an eternal tapestry. Perhaps the measure of significance lies not in survival or comprehension, but in the capacity to perceive, to reflect, and to bear witness, to recognize, even in our smallness, that we are participants in a story that is infinite, recursive, and profoundly beautiful. The idea of another Big Bang is not just a question of physics. It is a mirror turned toward the human spirit. For in asking whether creation might happen again, whether universes might rise and fall like breaths drawn and released across eternity, humanity is, in truth, asking about itself. What is life? What is a civilization? What is a species, if not a fleeting burst of order against the entropy of time? Every child born is its own kind of Big Bang, a sudden expansion from nothing into awareness, a singularity blossoming into memory, language, love, and imagination. And every death is its echo, a collapse back into silence. The cycles we live on human scales are faint reflections of the greater cycles the cosmos may follow. To sense them is to recognize that the story of the universe is also, in some deep sense, the story of us. Science offers glimpses into these cycles, tracing their shadows in mathematics, observations, and models. Thermodynamics reminds us that energy disperses, that order declines, that all warmth drifts toward cold silence. Yet quantum mechanics reminds us too of uncertainty, fluctuation, and emergence, that even within emptiness, reality is restless. These truths converge in a profound paradox. A universe that tends toward decay is also fertile ground for renewal. Out of collapse may come rebirth. From the ashes of stars arise planets, oceans, and life. The Big Bang is not only a beginning, it is a rhythm, a reminder that endings themselves contain the seeds of new beginnings. Humanity, fragile and brief, has found itself in a cosmos where destruction and creation are not opposites, but partners. In an endless dance, the emotional weight of this realization is heavy. To live in a universe with a beginning is already unsettling. It suggests that time itself had a first moment, that everything familiar, galaxies, stars, atoms, arose from an origin beyond imagining. But to consider that there could be more than one, that creation may be cyclical or infinite, stirs something deeper. It awakens both dread and comfort. Dread, because it implies that everything known, including humanity itself, may dissolve into oblivion, to be replaced by forms unrecognizable. Comfort, because it means creation never truly ends. Life is fragile, but existence itself is indestructible, continually transforming, continually becoming. Philosophers have long wrestled with this. The ancient Stoics envisioned cosmic conflagrations, great fires consuming the world, only to be followed by new creations. Hindu cosmology speaks of kalpas, vast cycles of creation and destruction, worlds breathed in and out by Brahma across infinite spans of time. Modern cosmology echoes these ancient intuitions, but with equations instead of myths, satellites. Instead of scriptures, whether in Tolman's oscillating models, Penrose's conformal cyclic cosmology, or brane collision theories, the suggestion is the same. Perhaps existence has no finality, no singular end, but moves instead through patterns, endlessly recurring, endlessly unfolding. In contemplating these models, humanity partakes in a tradition as old as thought itself. The recognition that the universe is too vast to be bound by linear time, too mysterious to be confined to a single beginning or a final silence. There is, too, a deeply personal dimension to these reflections. To live is to experience time as a one-way current, pulling everything forward into the unknown. Childhood recedes, loved ones depart, civilizations rise and fall, yet within memory and imagination, cycles persist. Songs are sung again, stories retold, seasons repeat their patterns. In this sense, human life itself becomes an echo of cosmic cycles, a small-scale mirror of infinite recurrence. Perhaps this is why the idea of another Big Bang resonates so deeply. It is not merely scientific speculation, but an archetypal reflection of human longing for renewal, for continuity amid impermanence. If the universe itself can be reborn, perhaps endings are never absolute. Perhaps even loss is part of a greater cycle of return. Still, awe mingles with fragility. If a second Big Bang were to ignite right now, the Earth, the stars, and every trace of humanity would be consumed in an instant, erased without witness. The scales of energy involved are beyond comprehension. The very laws of physics would be rewritten in this light. Human achievements, cathedrals, poems, discoveries, and dreams seem like fragile sparks. And yet, within those sparks is something remarkable: awareness. The universe has existed for billions of years without thought, without reflection, without questioning. Now, through humanity, it contemplates itself, wonders at its own origin, dreams of futures it may never see. In this, there is a strange immortality. Even if the physical traces of humanity vanish, the act of having wondered, of having reflected upon the possibility of cosmic rebirth, is woven into the fabric of existence itself. It cannot be undone. Consciousness, even if brief, is part of the story. The scientists who probed these mysteries, with telescopes scanning the first galaxies, with detectors listening for the whispers of gravitational waves, with accelerators smashing particles in echoes of the primal fire, are heirs to an ancient impulse. They are seekers, standing at the edge of knowledge, staring into the unknown with both fear and fascination. What they pursue is not only data, not only equations, but meaning. They may not phrase it in such terms, but their work embodies humanity's oldest question: why is there something rather than nothing? And if there has already been one act of creation, could there be another? In this search, human effort becomes cosmic poetry, fragile beings reaching toward truths that may lie forever beyond their grasp, yet refusing to stop reaching. In the end, perhaps the significance of asking about a second Big Bang is not whether it will truly occur, but what the question itself reveals. It reveals a species unwilling to accept the limits of perception, unwilling to stop at mystery, unwilling to surrender to silence. It reveals that curiosity is stronger than fear, that imagination is more enduring than despair. In imagining the universe reborn, humanity asserts a belief, not in certainty, but in possibility. The cosmos may be vast, indifferent, and overwhelming, but within it burns a small flame of consciousness, daring to dream of beginnings beyond endings. And so the narrative circles back upon itself. Much like the universe it seeks to describe, the question of a second Big Bang is less a prediction than a reflection of cycles in nature, of longing in the human heart, of the strange symmetry between endings and beginnings. Whether or not such an event will come, the idea itself becomes a kind of creation, a spark of thought that expands into wonder, echoing the expansion of the universe itself. In this way, humanity participates in the very rhythm it contemplates, becoming not merely observers, but storytellers, weaving meaning from the silence of the stars. Perhaps then, the truest closing reflection is this: creation is not a singular moment in the past, nor a cataclysm waiting in the future, but an eternal story in motion. Every star that ignites, every consciousness that awakens, every question that arises is part of that story. If another Big Bang were to come, it would not be the end, nor even the beginning, but a continuation of a song without final verse. And humanity, fragile though it may be, has added its voice to that song, echoing across the void with wonder, awe, and the timeless question: what lies beyond the next dawn? The thought of another Big Bang is more than a speculation in physics. It is a mirror turned toward the human condition. It is an echo of humanity's longing to know whether creation is a singular event or a repeating pulse, whether existence itself is fragile and finite or woven into an eternal pattern. To contemplate a second act of Genesis is to confront the paradox of life and death on the largest possible scale. For the universe, like humanity, exists between moments of birth and silence, between light that blossoms and light that fades. And so the question resonates not merely in equations, but in the heart. Could everything, even now, be poised on the edge of renewal, waiting for the breath of creation to pass again across the void? From the moment scientists first realized the universe had a beginning, unease settled upon philosophy. The ancient dream of an eternal cosmos, stretching infinitely into the past, was suddenly replaced with something unsettlingly finite. Time itself had a first moment, space a first breath. But if there was one beginning, what prevents there from being another? Cycles define existence in every realm familiar to human life: the rise and fall of civilizations, the ebb and flow of tides, the heartbeat and breath, the turning of seasons. Why should the cosmos itself be exempt from such rhythms? To imagine a second Big Bang is to imagine that the universe too may have its seasons, its pendulum swings between silence and creation, collapse and rebirth. Science, of course, grounds these reflections in data. The cosmic microwave background hums with the afterglow of the first fire. Galaxies recede, the fabric of space-time stretches, dark energy pushes everything apart. Observations have revealed a universe not static, but restless, not fixed, but evolving. Yet the equations of relativity, when pushed back toward the beginning, converge toward singularity, a boundary where the laws themselves dissolve. Beyond this veil, speculation begins. Bounces, cycles, collisions, emergencies. The Planck epoch, that unreachable instant less than a trillionth of a second after creation, remains a horizon science cannot yet cross. And it is in this hidden frontier that the seeds of another beginning might reside. For in physics, boundaries are not always endings. Often they are thresholds. Philosophy presses against this threshold too. For every beginning implies a cause, every moment implies a before. To say that the universe had one Big Bang is to leave open the question of what lay beyond, of what may lie before and after. If a second Big Bang were to ignite, it would not only remake the cosmos, but remake the concept of time itself. Time would fracture, restart, unspool anew, leaving the past unreachable, preserved only in the faintest echoes of radiation and gravity. To live in such a reality is to realize that memory itself is fragile. Humanity's entire story, every cathedral, poem, and discovery could vanish in the flash of a new birth, not because they lacked meaning, but because creation itself is indifferent to permanence. And yet, in this indifference, there is also a strange kind of promise. For if reality can be born again, then existence itself is inexhaustible. The universe may erase, but it never ceases. In this sense, every life is already a small rehearsal of cosmic cycles. Birth is a singularity, an emergence from nothingness into awareness. Death is a collapse, a return to silence. But in each new generation, in each child, existence begins again. Families, cultures, and civilizations rise and fall, but the pattern of renewal endures. What humanity fears on the scale of the cosmos, the loss of all that is known, is already a truth lived in miniature. And yet within that truth is beauty. Each moment, each breath, each fleeting act of creation is precious precisely because it is temporary. To imagine another Big Bang is to magnify this pattern to the ultimate scale, to see the universe itself as a phoenix, rising again and again from its own ashes. But awe carries with it fragility. If another Big Bang erupted this instant, no human would survive to witness it. The earth, the stars, even the atoms composing living beings would be torn apart, rewritten in fire and expansion. Human history, with all its struggles and triumphs, would vanish without trace. The scale of violence inherent in such an event is incomprehensible. It is the very fabric of space itself unraveling and reforming. And yet, this fragility is precisely what makes awareness meaningful. For amid vast cycles of creation and destruction, consciousness arises only briefly, a flickering candle in a cosmic wind. That it exists at all is astonishing. That it dares to wonder about its own impermanence, even more so in contemplating another Big Bang. Humanity confronts not only the fate of the cosmos, but the fate of meaning itself. If everything is erased, does anything truly matter? Or does meaning lie precisely in the momentary, in the fragile sparks that flicker before vanishing into night? A flower blooming in the desert is no less beautiful because it withers. A star shining across the void is no less real because it will collapse. And a life is no less significant because it ends. In the same way, a universe that may vanish and reappear does not diminish the present one. It amplifies it, framing existence as part of a rhythm beyond measure. Scientists, with their instruments and theories, stand at the edge of this mystery. Their work, grounded in equations and evidence, becomes part of a greater human attempt to reconcile the finite with the infinite. The James Webb Space Telescope peers toward the first galaxies, catching glimpses of the universe in its infancy. Particle accelerators recreate fragments of primordial fire. Gravitational wave detectors listen for ripples in space-time that may carry whispers from moments close to birth. These efforts may never resolve the ultimate question, whether another Big Bang awaits, but they embody humanity's refusal to turn away from mystery. They are proof that curiosity is stronger than fear, that the search for knowledge persists even in the face of cosmic silence. The final reflection, then, may not be about the certainty of another Big Bang, but about what the question itself reveals. It reveals a species small and fragile, living on a pale blue dot in the immensity of space, yet daring to ask about the fate of universes. It reveals a consciousness that sees beyond its own mortality, imagining cycles larger than galaxies, timescales longer than eternity. It reveals that, in some way, humanity participates in creation not by enduring forever, but by asking, by imagining, by weaving meaning into the unknown. And so the story closes as it began, with mystery. The universe may be a singular story, or it may be an endless song, its verses written in fire and silence, its rhythm the pulse of creation itself. If another Big Bang comes, it will not be the end, nor even the beginning, but another stanza in an eternal poem. Humanity, fragile though it is, has added its voice to that poem. And as long as awareness endures, as long as questions are asked, the universe will never be silent, for within it there will always be a spark that wonders, that imagines, that whispers into the void. Beginnings have no end.